Welcome to the Chapter 3, Part 4 video. In this section, we're going to be looking at properties of logarithmic functions. This is the last section that will be on the quiz, which will be assigned after our next class. So remember, the most important property of logarithmic functions is that they are inverses to the exponential function. So the properties that we're going to be looking at today are going to feel backwards to our properties of exponents. There's just two topics that we're going to cover, which is properties of logarithms, those being the opposite properties of exponential functions. And then a new property called the change of base formula, which again, with some practice, it will become a very handy property to use. Why do we care? Applications of logarithms are based on their many special properties, so we need to understand them in order to properly apply logarithmic functions. So let's look at some of these properties. First, we're going to give ourselves some restrictions on our variables so that we have logarithmic functions. We want b, r, and s to be positive real numbers, our positive base, because remember, when we have a negative base, the function is not continuous. It's not a logarithmic function. And then we want our argument also to be positive because of its role within the logarithmic function. Okay, and our base is not going to be 1 because then it wouldn't be logarithmic. It would be a line. Okay, and then C, which we'll use in our last property, has to be any real number. So that one can be negative, that one can be a fraction, that one can be irrational, it can be any number. Okay, so the first thing that we want to look at our product rule. Now notice product applies to the argument of the logarithmic function. So when we're talking about the product rule, there we go. The product is inside of the log. It's log of a product. And what we do with that rule is it becomes a sum of logs. Now, if we look at this as an exponential function, that would be the same as saying b to the r times b to the s equals b to the r plus s. Okay, so notice it's backwards. Here we had two bases multiplied together, and then they get added in the exponents. Here we have one base and our arguments are multiplied, as opposed to when I have two bases, they are added together. So opposites, these are the opposite. Okay, the quotient rule is dependent on the product rule. So in the quotient rule, we're essentially saying, what if S has a negative exponent? So instead of multiplying, it's division, right? R times 1 over S. Well, 1 over S is S to the negative 1. So I can say this is log B of R over S equals log B of R times 1 over S, or log base B of R times S to the negative 1. Okay, well, because of that negative 1, I can write this as log base B of R plus log base b of s inverse, or s to the negative 1, the reciprocal of s. And we're saying that that equals log base b of r minus log base b of s. So what we've done is we've taken that negative 1 and we've used it as a coefficient instead of an exponent. So that ties us together. The quotient rule ties us into what we call the power rule. The power rule says if my argument is raised to a power, so this is r to the c, the power can be written out front. And let's look at this again in the light of the product rule. If we're looking at the power rule, if I have log base b of r to the c, I can say that's log base b of r times r, c times. There are c of these, which means that this is log base b of r plus log base b of r, right? Our product rule says each product becomes a sum. Okay, and then I can say, well, those are all the same, so I'm multiplying them. I'm adding it to itself c times, which is the same as multiplying it by a coefficient of c. Okay, so These are our rules, and they all stem from that product rule. Okay, so if we understand the product rule, then we can derive the power rule and the quotient rule from the product rule. And the key to making sure we use these rules correctly is to remember the name. The product rule is regarding the product inside of a logarithm. The quotient rule is the quotient inside of a logarithm. And the power rule is the power of the argument inside of a logarithm. Okay, so then the critical thinking question becomes, what if I have log base b of r times log base b of s? Well, we don't have a rule for that, because while this is a product, it's a product of logarithms, not a product within a logarithm. So this is not the product rule. We cannot apply the product rule when we're multiplying logs. The product rule is actually when we add two logarithms, because then we multiply the argument. Okay, so let's see if we can apply this. We're going to look at an example here, and we're going to start with an example that is condensed. It's written as a single logarithm. And what we want to do is we want to write this as an expanded version. We're going to expand this out to be the sum or multiple or product of logarithms. Okay, so the first thing that we want to do is we want to look at this argument, and we want to write it as kind of like factoring it. We want to write it as all of its factors. So this is 3 times x to the 5th. So I can say that log of 3x to the 5th, which we can write as log of 3 times x to the 5th. Well, that's a product, so we're going to use the product rule. And the product rule says then I take log, same base, which is just our common base because there's no base written. Log of 3 becomes plus log of x to the 5th. Okay, so now I'm going to take a closer look at 3. 3 is just 3 times 1. It's already prime, so we can't simplify that anymore. X to the 5th, though, is 1, 2, 3, 4, 5 factors of x. And so we can write this as log of 3 plus log of x times x times x times x times x. Okay, then we can apply the product rule again, or because this is x to the 5th, we can apply the power rule. So that says that this is log of 3, can't be simplified, but this becomes plus, the exponent becomes the coefficient, 5 times log of x. To see how we get this from the power rule, from the product rule rather, how we get the power rule from the product rule, if we look at this as log of x times x times x times x times x, this would be log of x plus log of x plus log of x plus log of x plus log of x. 1, 2, 3, 4, 5. And if I have 5 of the same thing added together, that's 5 times log of x. So that's how we can get the same thing using the product rule. And that shows how the power rule comes directly from the product rule. Okay, so now in my argument, 3 is prime, x can't be factored any further. So then this will be my final expanded answer. Okay, if we have log of 9, okay, even though 9 is just a number, we still need to factor that 9 is 3 times 3 or 3 squared. So then I can write this as log of 3 squared, and that's 2 times log of 3. So when we're simplifying, even our numbers, we want to write them so that the argument of a logarithm is prime. Cannot be factored any further. Anything that's not prime, we can simplify further, okay? So if this was log of 6, let me use a different color. If we had log of 6, then I would write that as log of 3 times 2, which is log of 3 plus log of 2, right? So I'm going until the argument of my logarithm is completely prime. Okay. Now let's try one going backwards. So we took a condensed logarithm, a logarithm that has just one log, and we expanded it out as much as possible. Let's see if we can go the other way around. So this time we're given an expanded logarithm and we want to condense it. So we want to write this as a single logarithm. So the first thing that we have to do is recognize that these are the same base, right? If you look back at our properties, one thing that they have in common is that the logarithms always have to have the same base, that base b. We cannot use the properties of logarithms with different bases. So in this case, we have a natural log, which means our base is e. And so if I want to combine these, I need to get my natural logs to have no coefficients. That was our last step when we were expanding. It's our first step when we're condensing. I need to be able to combine these logarithms, meaning they cannot have any coefficients. So we have to take care of this 3 and also the -1. So we're going to write this as 3 times the natural log of x plus -1 times the natural log of 2. The exponent and the coefficient are the same value. So the coefficient becomes the exponent or the exponent becomes the coefficient. And therefore we have now natural log of, let me try writing that again, natural log of x cubed plus the natural log of 2 to the -1. So we're using, again, that power rule. Now that we have natural log and natural log with no coefficients, we can combine the arguments. This is added together, so we're going to use the product rule. So now we'll use the product rule to say natural log of, I'm going to do the product of x cubed and 2 to the -1. And now it's as a single logarithm, but I want to simplify the argument as much as possible. So if I had x cubed times 2 to the -1, I wouldn't leave it in that form. I would always write it with positive exponents. So that becomes x cubed times 1/2 or x cubed over 2. There's nothing else I can simplify. It's already as a single logarithm. And so that is my final condensed answer. Okay, so our first step was the power rule. No coefficients. Our second step was the product and quotient rule. And that is combine to a single log. And I guess step 0 would be check bases. Okay, and then we can condense this into a single logarithm. So it's the opposite of when we were expanding. When we were expanding, we factored in order to get to use the product rule, and then once we had the product rule, we factored out the powers. Okay, our last property that we're going to talk about is the change of base property. And the change of base property is important because your calculator has a button for the common log and it has a button for the natural log, but it does not have a calculation feature for log base 7, for example, right? So if I have a log with a base of 7, in order to calculate that, we need to convert it into a common log or a natural log. And so for any positive real numbers, a, b, and x, where a and b are not 1, so again, our bases have to be positive and not 1, we can say that log base b of x, we drop the base to the basement, becomes log base, whatever base we want, base a of x divided by log base a of b. So we can change the base to whatever we want. Now, normally, we're going to write this as log of x over log of b, or the natural log of x divided by the natural log of b, because those are the ones that our calculator can calculate. So let's look at an example. I'm looking at this log base 3 of 10. Okay, well, I can't put that in my calculator because it's not a common log and it's not a natural log. So I'm going to take base 3 and drop it down to the basement. Drop the base to the basement. So this becomes log of 10 divided by log of 3, and I could have chosen any base. Okay, now I chose the common log because notice I have an argument of 10. So if I chose the natural log, I wouldn't be able to simplify this. But with the common log, log of 10 or log base 10 of 10, the base is reduced and that becomes 1 divided by log of 3. Now that we can put directly into our calculator to calculate it. So we can look at our calculator, and in order to calculate this, we want 1 divided by, this is a common log, so we're going to use log of 3. Now, because log of 3 is a single calculation, I don't need parentheses around it. However, if you're more comfortable grouping together the numerator and denominator, I always encourage you, parentheses are free, so we can always put parentheses around the denominator as well. And then we will find that our value here is 2.0959. Always rounding to 3 decimal places in this class is 2.096. So looking back at our original problem, and so we have that 1 divided by log of 3 is approximately 2.096. Okay. That is it for this section. Now, those properties, we're going to practice applying them in class. I also have uploaded an optional practice with these if you wanted to start thinking about it before class. And that way, if you have any questions during class, you can get those asked before the quiz. So we have class again on Tuesday. We'll have class on Tuesday where we will review these properties. We'll get some practice in. Tuesday's homework will be the quiz, and the quiz will be due on Thursday at midnight because then we have class again on Friday. Okay, so the homework from Tuesday to Friday will be the chapter 3 quiz going all the way out through the end of this section, so including the properties of logarithms. Email me if you have any questions. Otherwise, I will see you in class.